We recheck the cause of the interference. It is suspected to be the grounding of the platform. We grounded the entire platform. The platform is grounded to the earth, and we plugged the blue USB cable to the back. It cannot be plugged in the front. In addition, we also grounded the computer shell. So we can see that there's no problem with the current data. It is all normal. The next step is the software here. You can collect the current DC power meter, including voltage, current, and this power. Let's look at the next column of the 3-phase multifunction meter. This is a 3-phase multifunction meter. Because the 3-phase multifunction meter is not connected to other lines, we just let it run, so it only shows the current voltage of one of the atoms. This experiment does not use it. Let's take a look at the other DC power supplies. This is the current DC power output voltage and current. This can correspond to the power supply side. Next, we turn on this load. There are 3 loads here. After coming out of this load end, a load module is connected. We turn on the power. First, let's try the following. Then turn on another one. Another one. These are 3 types of bulbs. Incandescent lamp, LED lamp, and a fluorescent lamp. There's no problem with the data. There's no interference now. Let's demonstrate this data export. We use the mouse to leave the desktop. Use the mouse to slide down. We export the DC power here. The data just now is here. Click in the lower right corner. We choose to export to the desktop. The format saved now is XLS. Choose to save to the desktop. Because we have exported the second table today, we don't have data now, so it is also blank when exported. Oh, only the first column UV has voltage. We also save it. Distinguish the data. The third column has data. The third column is for DC power supply, also exported. There are 3 tables on the desktop now. We can take a look at the first column. This will display some current data. Let's take a look at the first column again. Look at data table 2. You can see that the first column will display the serial number. The second column is the time. You can click to see. Select 176. 6 is the serial number. The time after this measurement is January 14th, 2024. This is the voltage and current data. This is the form of the data table. You can also export this data table into CSV format. There are some other data formats we can use. Return to the software. This is the data of this. Then we turn off this light bulb. This is its status. Now it is a situation where both photovoltaic panels and municipal electricity are powered. Let's test it again without photovoltaic panels connection. Turn off the photovoltaic panel. Turn off the power supply. You can see that the symbol of the solar photovoltaic panel is gone. Then we are now equivalent to a city power supply. Only the panel situation is powered. We will power it again. The same photovoltaic inverter is also possible. The hybrid inverter is also possible. Next, let's test it again in the absence of the city power. What is the situation when only the battery is used to power the load? We will use this hybrid inverter circuit breaker of the device. The circuit breaker of the AC power supply is disconnected. You can see that the current input side is 0 volts. Now the battery is directly inverting. After generating 230 volts of AC, power the light bulb load. Started. Power supply. Then let's look at the side. It should be noted that if you use this load for power supply, you need to turn on this switch. Turn off. This way the test is completed. After completion, unplug the battery.